Design of an elevator system is one of the most common but also one of the most complex low-level design interview questions. There are too many scenarios to consider, and if you try to put everything in the same class, then your code is going to become very complex very quickly. So what I intend to do in this video is I will keep the explanation simple and short enough to fit in a 45 to 60 minutes face-to-face interview, while also covering all the aspects that your interviewer will want you to discuss. So let's get started. Design of a simple elevator system requires you to do one thing. Basically, you have to recognize how the behavior of an individual lift in the whole lift management system changes depending on different parameters like the floor lift is at, or the direction lift is moving, or how many people are inside the lift. So all these parameters, how they are changing or affecting the behavior of the lift. And once you recognize that, you will break all these, the implementation of lifts behavior in different state classes. So what we are going to do is we are going to go through all the requirements that this system should satisfy. Then we are going to break whole solution in multiple different classes and use state design pattern to design our solution. Finally, we will have our completed Java code, which we will basically copy and paste in the CodeZym editor and run tests against it. Once our test successfully passed all the basically all the test cases that are in the CodeZym testing engine, then we will be fairly confident that our solution is correct. And if you get the same question in the interview, then we will do well there also. So let's get started. Now let's go through the different requirements for this elevator system one by one. The first thing that we do with an elevator system is we request the lift. So we are in the lift corridor. So what we do, we go and press the either up or down button on any in front of any of the lifts, and we get a lift number and we go and stand in front of the lift, wait for it to come to our floor. Now there are a few things that we may need to consider. Even though we have requested a lift to our floor, when it comes to our floor, we may or may not enter it because the lift may be full when it comes to our floor, or we may have taken another lift, or we may have taken the stairs by then. Again, only one person may request the lift, that is press the up or down button, but multiple people may enter it. So there are 4 or 5 friends, only one of them presses the up or down button, but all of them enters the lift when it comes to their floor. Now direction is denoted U for up, D for down, I for idle, which we will see later. Now let's come to the second requirement. What happens when the assigned lift comes to our floor? We enter inside the lift and press the destination floor button. So this is press floor button inside lift. So this lift index was the lift that was assigned to us, and floor is our destination floor. Now again, there are a few things to consider here, or assumptions here. Do not worry, your interviewer will allow these assumptions. So now we need to accurately track the number of people entering inside the lift. So the first assumption is each person entering inside the lift will press the destination floor button exactly once. This is done to keep track of the number of people entering inside the lift. Now in real world, generally lifts have a weight system, like this lift can carry only 400 kg of people, and when it's full, it gives a beep beep sound, and it means some people may have to get off. But here we have just taken, to simplify things, we have taken the count directly, and for accurately tracking that count, each person entering inside the lift will press their destination floor button exactly once. Now again, when you cannot enter a lift which is already full. So if the capacity of that lift is 4 and there are already 4 people inside, you cannot enter that lift. The third is if, so this method cannot be called then. Again, let's suppose you enter inside a lift, you are at floor 4 and that lift is going up. You cannot enter a destination floor like 3 or 2 or 1, that is you cannot reverse the direction of the lift. So if the lift is going up, you have to uh, press a destination floor which is in the up direction only. Now we'll see exceptions to this case, but these are the few things that we should keep in mind for this second requirement. Next, the lift management system may also want to track the state of a lift. So basically a state of a lift is made up of three things. The first one is the floor on which that lift is at. The second one is whether it is moving up, down, or is standing idle at some floor. And the third one is how many people are inside it. So let's suppose get lift state has returned 4-u-8. It means lift 0 is at floor 4, it is moving up and there are 8 people inside it. So this is how you track or return the state of the lift. Finally, we need to some way to simulate the working of a lift. In real world, there will be actually two events. The first one will be when the lift stops on a floor and its doors open. So that will be the first event. The second event will be all the people have entered the lift and its gates have closed and it has started moving up from or down from that floor. At this point, even if someone presses the up or down button on that floor, that lift will not be selected. So these will be the two events which will be used to track the movement of a lift in real world. But in our case, let's simplify things because we want to keep our discussion simple. So let's assume that each lift in our system will take exactly 1 second to reach the next floor, whether it is moving up or down in any direction basically. And the amount of time for people when the lift stops on a floor, then the amount of time for people to get out and other people to come in inside the lift is 0 seconds. So it doesn't take any time. So it takes only 1 second and stoppage time is 0 seconds on any floor. So we do not consider that. And finally, we assume that this method tick is called every 1 second by the system. So when tick is called, it means you have to update your system state of each of the lift. If the lift was going up and it was at floor 4, then move it to floor 5. And we will use this tick method to track the seconds that have been elapsed rather than using the system time. So we have our assumptions with this method and we have all our requirements. So let's get started with the class design. You can think about a lift management system as nothing but a collection of lifts. So an individual lift class will be the most important, or you can say the backbone of this system. So what an individual lift will track? First, it will track which are the incoming requests, that is on which floor a lift will stop and people may get inside it or may not. Again, it will track which people are inside this lift and on which floor they will get off so that it will stop on that lift. It can count based on the outgoing request, it can count how many people are inside the lift. Again, it will also track the direction of the lift, whether it is standing idle or it is moving up or it is going down. It will also track on which floor the lift is currently at. So these all things, the number of people, the floor and the movement direction form the state of the lift. Apart from that, the most important thing a lift needs to do is it needs to be assigned to some request. So for that we have the method get time to reach floor. So for every request, what the lift management system will want to do is it will call this method on each lift and find out whether how much time will that lift take to reach that floor in that given direction. So this method returns that time, or it returns -1 if the request is invalid for it. If there may be regions, the lift may be moving in opposite direction or something. The second thing it needs to track is when that lift reaches that floor, will it be full or will there be space left? And that is why this count people method is there. So it counts how many people will be inside that lift. It counts only from the people who are already inside that lift and how many of them will get off after that floor. So those people will be inside that lift. So let's suppose there are 6 people inside the lift and all of them will get off after floor 5 only, and the capacity of lift is already 6. So we cannot take a request for floor 4 or floor 5. So these are the things a lift is going to track, and we will see these things in more description or in better way as we move ahead. One important thing which we need to notice is the behavior of a lift changes with the state of the lift. State is the floor lift is at, the direction in which it's moving, and the third, the number of people inside the lift. So let's see a few scenarios. Let's assume a request comes from a person who is on floor 4 and they want to go in the up direction. All the lifts in the building are of capacity 4, so maximum 4 people can be inside the lift. So what the lift management system will do is it will call get time to reach floor for all lifts. Okay, for this and see what times they will return, and it will choose the optimal lift based on that time. So let's suppose a lift was at floor 4 and it is moving up. So it will return 2 seconds. 4 minus 2, 2 seconds. It will take 2 seconds to move 2 floors up. If the let's take another lift which is at floor 5 and it is going up. Now that lift cannot be assigned this request because it is already at floor 5, so it is past floor 4. So it will return -1. That is invalid for this request. Now let's suppose another lift which is what at floor 5 but it was going down, or was at floor 4 but was going down. So those lifts can also not be assigned to this request. Why? Because they are moving in the different direction or opposite direction, and you cannot change the direction or move direction of a lift. Let's suppose another lift which is at floor 1, it is moving up, but there are already 4 people inside the lift, and all of those 4 people will get off after floor 4. So they will get off after at floor 5, 6, 7, 8 or something like that. Now again, this lift also cannot be assigned that request. Why? Because the lift capacity will be full. It will already have 4 people when it reaches floor 4. Another case, same thing. There is a lift on floor 1. It has 4 people inside, but at least one of them has a destination floor as either floor 4 or 3, floor 2 that is below or equal to floor 4. That means by the time lift reaches floor 4, there will be at least space for one more person. So yes, this lift will return a positive time, that is 4 minus 1, that is 3 seconds. So these are the different scenarios, and you see that based on the direct movement direction of the lift, and again based on the floor on which the lift is at, and again the capacity of the lift, the behavior changes, and the get time to reach floor returns different methods. Again, the same thing can be said for tick method. Let's suppose lift is going up, it is at floor 4. So when the tick method is called, the current floor will become floor 5, that is it will increase by 1. Let's suppose the lift was going down, so the current floor would have become 4 minus 1, that is 3. So you see the different methods inside the lift class behave differently based on the state of the lift. So we can obviously make use of this behavior, or you can say phenomenon, to basically break the whole solution in multiple different state classes. Let's do that. Now we know that the behavior of some of the methods inside the lift class changes as with the state of the lift. So we are going to use state design pattern to solve this use case. This is and the perfect use case for this design pattern. So what we have done is we have kept all those common methods inside the class lift state: get direction, get time to reach floor, count people, and tick. Now there are 5 state classes. If you think about it, three basically, what are the states a lift can be in? So there are 3 states. One is a moving up state when the lift is moving up, moving down state, and idle state. But if you analyze a bit more, there can be 2 more states. The first one is, let's take an example. A lift is at floor 4, it is moving up, there is no one inside the lift, and it will pick its first passenger at floor 8 who will eventually go down. Since the first passenger inside the lift will go down, so even though lift is moving up, it cannot take any up requests. It has already been assigned to a down request. So this is a unique case here, that lift is taking the request against the direction of its movement. So this will be our moving up to pick first state. We will see how it behaves. Again, the opposite of it, moving down to pick first. So a lift is at floor 6, it is moving down to pick its first passenger at floor 2, who will, if they enter it, they will eventually move in the up direction. So again, even though it is moving in the down direction, it cannot take any down request. It can take only up request after floor 2. So these are the 5 states. So we'll see their behavior, and hopefully this will simplify our design. Our first implementation is the moving up state, which will extend the lift state. its direction will be up. For get time to reach floor, it will check that the direction of request should be up and lift should not have passed that floor. In either of the cases, it will be an invalid request, -1. We already discussed that. Else it will simply, since time taken to move up one floor is 1 second, so it will simply uh, reduce the destination floor minus the current floor lift is at. Again, for counting people, if the lift is not moving in up direction, it will simply return 0. Else it will, what it will do is, it will count all the people whose destination floor is greater than that floor. So number of people who will be on that floor in that direction. Now we have the tick method. So first of all, it discards the older requests. Then after discarding the older request, it checks whether the lift, there are no more incoming requests. If there are no more incoming requests and no more outgoing requests, it simply returns, because there, it means there is no one inside the lift. Else it will simply increment the current floor. If the lift was at floor 4, it will become floor 5, and it will remove all the people whose destination floor is equal to current floor. So all those people will get outside the lift or move out of the lift. So this is how this whole class behaves. Logic for the moving down state is very much similar to the moving up state. Direction will be D. It will also check for invalid requests, and here the current floor is up since lift is going down, so it is higher, so we will reduce the current floor minus the destination floor. For counting people, again it will check if the move direction, return 0, else it will count all the people who will move out of the lift after the given floor. So the people who are already inside the lift and their floor is less than floor. For the tick, again it will check if first it will discard the older request, then it will check if there is no lift has become empty, that is no incoming or outgoing requests are there, no more people are there. If that is the case, it will simply return. Else it returns because now the lift has come in idle state, there is no one inside the lift. As soon as everyone moves out of the lift, there are no more incoming requests, lift becomes idle, so it has to change its state, so it simply returns, and the lift class will change the state. So if that is not the case, the current floor becomes is reduced to 1. So if it was floor 4, now it has become floor 3. It had gone down 1 floor, and then all the people who has to move out are moved out of the lift. Implementation for the idle state is simplest. Direction will be I, and get time to reach floor will be simply the difference between the current floor and the floor in which we want to go. It's idle, so it means no one is inside the lift, so it can directly go there. Next, let's discuss how will the moving up to pick first state will behave. So this is a lift, no one is inside the lift, it is moving up, it will, let's suppose lift is at floor 4, it is moving up, it is going to pick its first passenger at floor 8, and that passenger, if they enter, they will go down. So movement direction is up because right now it is moving up only. Get time to reach floor, it will take the next stop. So what is the next stop? Next stop is the basically the floor of the first request. So let's suppose uh, an existing request already is there assigned to this lift for floor 8, and that person will go down. Now this lift cannot go higher than floor 8. It cannot take, or it cannot be assigned to a request to go down from floor 9 or floor 10. Why? Because it will increase the waiting time for the person on floor 8. Lift will first have to go to floor 10 and come down to floor 8 and then pick that person. So 2 seconds for going up, 2 seconds for coming down. So 4 seconds extra has been added to the wait time of the first person who had made the request earlier, and that is irritating. You do not want to increase your wait time. So it will go only until that floor, until floor 8 or the floor of the first request. So this is what next stop returns. It returns the maximum stop till now. So if the direction, and it can take only request in down direction. So if the direction is up, then it cannot take that request. Or, or if the floor is greater than next stop, then this is an invalid request. And that's how it calculates. So for calculating, First it will go till the next stop. Let's suppose a request come for 6D, that is to go from floor 6 till in down direction. So what will be the time it return? First it will go till next stop, so it will go till floor 8. So right now it is at floor 4, it will go till floor 8. So it will take 4 seconds to reach floor 8. From there it will move down to floor 6, that is 2 floors down. So it will take total 6 seconds to reach the floor 6 in down direction. So this is how this calculation is made. Go to next floor from current floor, and from next floor go to the destination floor. For tick again, it will simply, there is no one inside the lift, so no, you do not want to remove any existing or incoming or outgoing request. You simply increment the current floor by 1, and if we have reached the next stop, that is at the highest point of the basically the floor of the first request, then this state will convert the lift into moving down state. So it calls the lift to convert its state into moving down state. This is how it will behave. Now let's see the opposite case. A lift, no one inside it, it is moving down, it will pick the first passenger, and when they enter, that passenger will start going up. So its behavior will be similar, except that it will act as a moving down lift, which takes only request in the up direction. So move direction is D. For assigning a request, it will check if that its direction must be U, and the floor should not be lesser than the floor of first request, else it will return -1. Now to return the time to reach floor, first it will go from current floor to the next stop, that is lowest, and from the lowest it will go to the destination floor. So destination floor minus next stop. So this will be the time. Next stop will be the floor of the first request, just like in case of the moving up to pick first. Tick method, it is acting like, right now it is acting like a moving down lift, so it will reduce the number the current floor by 1, and if we have reached the next stop, that is the floor of the first request, then its state will convert into moving up state. So now it has to start moving up, so it's called the set state method there. Now class lift is going to use all these state classes to simplify the implementation of its different methods. They would have been complicated had we not used these states. So it initializes all these state methods once, moving up, moving down state, idle state, moving up to pick first, and so on. And there is the current state of the lift. It initializes with idle state. For get time to reach floor, it simply calls the state method current state dot get time to reach floor. For counting people, it does the same. Same for get move direction, and same for tick, except after calling tick, it checks if there is no one inside the lift. If there is no one inside the lift, and that is there are no outgoing requests, and there are no incoming requests either, that is no one is coming inside the lift, then it sets the state to I, that is lift again goes back to the idle state on that floor only. There are other methods, simple methods, and their implementation is done. But the important methods, their implementation is directly, basically, you can say, given to the, they are implemented through the state methods. A lift management system is nothing but simply a collection of different lifts or multiple lifts. So we have class solution, which acts as the lift manager, or you can say the lift management system. So this class keeps the list of all the lifts in the building, and it initializes each lift with the number of floors in the building and the capacity, which is the lift capacity. It can be 4 people or 10 people or 2 people. Now it implements the different functionalities or the requirements of the system that we discussed in the beginning using the methods of the lift class. For example, for requesting lift in a given floor in a given direction, it goes through all the lifts, gets the time to reach floor, and discards the lift if the time is invalid, that is less than 0, or there will be more than capacity, that is the lift will be full when it reaches that floor in that direction. If both the criteria are satisfied and the lift is valid, then it compares, it needs to find the optimum lift. So it compares with the existing time and lift index. If the time is less, then it picks. If the time is equal and the So basically if the time is left, it simply picks. And finally it returns the optimum lift index. For pressing the floor button in lift, it simply picks the given lift from the list of lifts and calls the add outgoing request. Same for tick, it goes through all the lifts and call the corresponding tick method in the lift object. For getting the lift state, again, it simply picks the relevant lift and calls its method to build the state of the lift. So lift doesn't need to know what an state will look like. Also, it doesn't deal with the basically different state classes. It only deals with the lift at the lift layer. So this gives us a abstraction and makes our code simpler. So we have the solution class or the tester class, you can say it, or it is also the lift manager or lift management system at the top. After that, we have the class lift, and that class lift uses all the different 5 state classes to implement the different behavior of the list, and we have a simple design for the elevator system. Now we have it, let's test it. Now we have completed our Java code solution for lift management system. So let's copy paste and test it. And before that, do not forget to comment the helper code at the bottom, else you will get compiler error. So let's copy this whole code and paste it in the CodeZym editor. So this is question number 11, design simple elevator system. Let's convert this to Java and paste it here and run it. It is going to take some time to run. So initially it will compile, and as it runs, it will show the test cases one by one. Code has successfully compiled and passed both the sample test cases. So now let's run it for all the test cases. Let's submit the code, and as it runs, you will see that right now it is compiling, and as it runs, you will see the test case numbers. All 14 test cases are passed. It took around 7.5 seconds. So now that we know that our code is indeed correct, and if you get this similar question in an interview, then we can confidently do it. So this was all about the solution. This was all about design of a simple elevator system in a building with multiple floors, and that system manages multiple lifts. So only one thing if you can take from this video, it's that you have to break the lift behavior in multiple states. That is, take out the common methods which change with the state of the lift, put them in a state and implement them using different state methods. That is all you need to figure out or do in a low level design interview. Now that was all. If you are preparing for low level design interview, then I will recommend you use codezym.com/roadmap. It's a 7-day preparation plan which will help you efficiently prepare for low level design interviews. It has got all the YouTube videos and questions that to practice questions and theory for the different important concepts that you will come across in your face-to-face or machine coding LLD interview. So it will help you prepare efficiently, and basically you will not get lost in the tons of videos on YouTube, and you will not get confused as to what to study, which topics to do first, which questions to do first, which videos to watch first. Everything is there at the same place. So I recommend you try it, and I wish you the best of luck for your interview preparation. Wish you get the job that you are trying for. Best of luck. Bye. Thanks for